Good morning, honoured guests, ladies and gentlemen. Despite the music, I'm not going to sing, so already you have something to celebrate. I think it's an immense privilege to be speaking at this conference, and I'm most impressed by all of the organisation that's gone into delivering what has so far been a most interesting and stimulating event. I should say at the start, though, that I come from Scotland originally, and from a Presbyterian tradition, which means that my character is inherently glum. I rarely look for the positive in messages, and I'm constantly worried about overstating the upside, and I look for the concerns and the pitfalls in everything. So a lot of what we've heard about is around buildings, and I'm going to move away from that a little bit as a way of expressing something around sustainability in a different context. But before I do, we've heard a lot about energy efficiency and renewable energy generation in relation to the built environment. And one of the things that struck me yesterday was that we talked about the 110-100 rule, where the 1 is the energy costs associated with a building, which means that energy is essentially unrealistically cheap. And whilst all of the efforts to make buildings more energy efficient are laudable, we need to do more than just make them more efficient, because buildings are responsible for 1/4 at least of all emissions. So the property industry is faced with an impossible situation. And what is needed is intervention by legislators to require near zero or zero energy buildings accompanied with an upfront cost to be met for the lifetime carbon of that building, which makes the cost associated with the capital investment rather than the running costs, because the separation of capital and running costs is often one of the problems associated with energy efficiency in buildings. And fines should be imposed for exceedance. There are so many exciting initiatives, but we need to know the carbon impact of each. And from the huge array of initiatives, exciting developments that we've heard about in the last couple of days, we still need far more information about which initiatives will make the greatest difference. We heard some really encouraging messages. For example, 20% reduction by 2020 is a real target that Swire have imposed upon themselves. And that kind of binding target, which is made public, is the kind of commitment that I think that we should be looking for. But the end game is 80% reduction of all emissions by 2050, and we need to be careful that we're not locking in less than 80% in buildings that will still be operational at the point of 2050. I come from Cambridge. Well, I work in Cambridge. And it has, some people think of it as a bubble. I think of it as having its own alternative reality. But it has a global outlook, but from a very particular position. And I wanted to think about resilience, because we often use sustainable development and sustainability as if we all shared a common understanding. And even more so with resilience, we all feel that we know what it means, but we don't necessarily all have the same definition in our minds. There are many definitions, and I think it's pretty fruitless to argue about which is the best, but I think the UN's definition is very helpful. And it has many aspects. The one that I wanted to really focus on was the completeness of knowledge. The interpretation of resilience has led to competing views and uncertainties around how resilience should be described and measured. And unless we have improved knowledge around the kind of data that we're using, and we've repeatedly come back to having inadequate data as being a problem in the descriptions of the projects that we've heard about so far, we're not going to be able to make balanced and informed decisions. One of the bits of work that we've been doing in Cambridge is to try and position resilience so that professionals working, this is in particular in relation to disasters, can have a common lexicon, and that they therefore can have a shared understanding of what they're describing. And the use of this graphic allows professionals to describe which parts of these they are concentrating on when they're looking at resilience in a particular context. So they can apply it to different contexts, and this is taken from the literature, where the literature itself concentrates on different aspects. But in relation to a particular situation, it's possible for an authority or a group of engineers or a group of decision makers to decide where they are positioning themselves in relation to resilience, not only in response to a disaster, and this was developed in relation to the Christchurch earthquake of 2010 and then the 14,000 subsequent earthquakes in 2010 and 2011. So that there was a basis of understanding that was common to everybody involved in the process. Turning for a moment to the built environment and retrofit, this was an interesting Retrofit 2050 project, where we looked at the possibilities and the options for different futures of retrofitting the built environment in the UK context. Now, the UK's climatic conditions are very different to Hong Kong and Southeast Asia. It's essentially a very temperate climate, a very benign climate. And climate change will not have anything like the severe effects in the UK that it will have elsewhere in the world, although the impact on the UK will come from results elsewhere. But one of the most shocking things that emerged from this work is that if the government's plan for retrofit is rolled out to the fullest extent that it is physically possible to do it, despite the fact that emissions from buildings in the UK account for 27% of all emissions, the whole retrofit programme would only result in a 3% reduction in national emissions. And that's contrasted with if we were able to persuade the residents of domestic buildings only to reduce the average temperature of their homes by 1.6 degrees compared to 2007 levels, which is not long ago, a reduction in average room temperature of 1.6 degrees compared to 10 years ago would result in a reduction of national emissions, total national emissions, of 9%. In other words, a change in behavior in a temperate environment would lead to 3 times the impact of the effect caused by physical intervention. And we forget to include the communities, occupants, and residents of our buildings in the process because we get fixated on physical and scientific and technical interventions. Behavior change and an acceptance of the priorities associated with changing behaviors in a changing climate needs to be given far greater priority. Now, this work resulted in developing some scenarios, and I am a firm believer in the development of future scenarios, not to predict the future, but to create a space within which the future will almost certainly exist. By creating the extremes, we can be confident that the actual future will be somewhere in this space. And these three scenarios looked at a smart networked city, a compact city, and a self-reliant green city, and looked at the different outcomes that would eventuate from these different types of scenario. The value of this work is that you can then start to plan for resilience, because if you can develop physical systems and governance systems which are responsive to 2 or 3 of the 3 scenarios, your resilience is increased over being able to only, if your interventions only respond to one of them. It makes you less risky in terms of changing futures. And in the same style, we did some other work in Cambridge associated with a major property owner and developer, Grosvenor Estates, who looked at, their original question was, what should we do to our built environment estate, which is residential, commercial, and public buildings, that gives us the highest chance of being robust, in their phrase, but resilient in our terminology, by 2040. So we created this 2x2 matrix and looked at 4 scenarios within which a credible future somewhere exists. And by looking at this in immense detail and with great calculation of what the energy costs would be for different interventions, both in terms of what the intervention would be and how much savings there would be, we were able to develop, against these 2 axes, a strategy which was most likely to be able to cope with 3 or at best 4 of these different scenarios. And the least likely outcomes would be those which only would work in one of the 4 scenarios. This kind of scenario building work is essential both to be able to get quantification of what the future may hold, but also to engage the decision makers in the process of buying into the process that this is not a decision which is only related to the delivery of a building on the day of commissioning or at the point of handover to a future tenant, but it's part of an overall process where responsibility lies with all of the stakeholders. And in another context, looking at 4 essentially eco-developments in the UK and Europe, a similar knowledge mapping process was developed in our group, which also looked at, in the same sort of style, at looking at different opportunities. I won't go through this in detail, but I put it in the slides because it gives you an opportunity, hopefully you'll have access to these slides, to be able to look at this work in more depth. It delivered a 3-axis approach, looking at accommodating risks and uncertainties, looking at coverage of sustainable development issues, and also adopting life cycle thinking. And each of the developments was tested for each of these 3, and the extent to which these developments had taken these different aspects into account. And future-proofing, in fact, in property development, and particularly in large mixed developments, is surprisingly absent. Because of the legislative environment, permissions are granted on the basis of current standards, which implicitly take account of some future conditions, but in a very minor way. And developers are driven by the legislative environment, which gets them to the point of commissioning and handover. Just by way of an example of the use of big data, we've been able to persuade Google to release Google Maps app data every 15 seconds for a percentage of phones in London in real time, delayed by 2 weeks. So that these are real-time data sets which can track anybody with a mobile phone with Google Maps app mounted on it. And by this method, overlain with socioeconomic data and other data from Transport for London, it's possible to build a real-time map of the movements in London by different modes of transport, from walking, cycling, taxi, car, bus, train, and underground. You do underground because the receptor disappears and then appears in another place. And this is an extremely accurate method. This method has the possibility, just handling this data in this way, of completely overturning the way we currently do transport planning. Because this is real data, it's not modeling, it's just reflecting what's going on. You can then model by turning off different connections in the city and seeing what the impacts are. So I want to turn to civil infrastructure, which is where I feel most comfortable and where I've got the longest experience. Civil infrastructure is the basis on which all of our society depends. It's often hidden. It's not very fashionable, it's taken for granted, and it's expected to work 100% of the time. With increasing efficiencies brought about by privatization of the delivery of infrastructure, the interdependency has become more critical because we have separate water companies, separate sewage treatment companies, separate telecoms, power supply, distributors, transmission companies. And so whilst all of these infrastructure elements are operationally interdependent, they are functionally independent. And even more so than buildings, infrastructure has the characteristic of long life. Many roads can look back several hundred years for their essential alignment. They require very high initial investment. They're geographically widespread and often linear, and they insist on compatibility with existing systems. But of course, this means that because you need compatibility with existing systems, new infrastructure tends to be dragged down, as it were, in terms of technical advance by having to comply with what already exists. And probably the greatest example of this is railways. The truth is that if we were starting from scratch, we would never separate roads and railways from each other. There is no logical reason to have an entirely separate and incompatible pair of linear mass transport systems which have no connectivity except at the points of stopping. Now, in terms of risk, decision makers at the World Economic Forum, they may not be scientifically the most reliable sample, but they are an impressive group of decision makers, very often chief executives and world leaders. And every year, the World Economic Forum does a global risk report. And it's surprising when you look from year to year to year in the World Economic Forum's risk report, how immediately responsive the sample of interviewees are to immediate past events. So in 2017, the 3 of the 4 top risks identified by them for impact are extreme weather, natural disasters, and water crises. And along the bottom is the increasing likelihood, and the vertical axis is increasing impact. The outlier up there is weapons of mass destruction. And it's very interesting that given that these are global risks which are perceived to have very high impact, world leaders identify these three rather particular and somewhat isolated risks as being the most dominant. What's shocking is that the failure of critical infrastructure comes 25th on their list of things to worry about. This is not, I don't think, to say that they think that infrastructure is the 25th most important thing that they should be thinking about, but it is to say that they think that infrastructure is most unlikely to fail. Now, that's not quite how it appears on this graph, but their assumption that infrastructure is a constant and deliverable service to society says much about how we view risk and resilience. Something that is not yet, I don't think, satisfied by research in the literature is that I'm firmly of the belief that resilience is inversely proportional to economic development. Now, this is counterintuitive and is contested by many people. But if you look at developing economies, the cities of, say, India or Bangladesh or most of sub-Saharan Africa are excellent at absorbing shock because their infrastructure delivery and their urban systems are broadly under strain the whole time, and they deliver only partial service. So the residents of these cities are prepared to deal with the absence of service. In cities like Hong Kong, London, New York, and so on, those cities are extremely strong, and the likelihood of failure is very low. This has two effects. One is that the residents become complacent and entirely dependent on a full, reliable service, such that when a service fails, there can be catastrophic consequences because the societies are not prepared to be able to deal with the loss of service. So currently we have a situation where we are increasingly concerned with 100% reliability and the elimination of risk. We have an assumption that we look for a total assurance of non-failure, and we assume that all failure is catastrophic. We want risk allocation to be confined so that we can blame somebody and sue somebody. And in pursuit of all this, we accept implicitly, but very rarely explicitly, that the use of resources now to deliver on this agenda inherently compromises future generations because those resources are being absorbed to meet our current needs. Now, this may be a sort of philosophical point, but I think that we have the potential to look for a different world that is subject to such threats as we've been hearing about already in the conference, and we will hear more about today. The climatic threats mean that our use of resources has to be more balanced. And we should probably be designing for failure to occur, to allow for graceful failure. That is a phrase that you never hear. We need risk to be shared more widely and resource use now to be balanced against the future impacts of not having those resources available. There are road building materials in Africa which have entirely been exhausted because the way in which we use those resources over the last 100 years has been profligate. In infrastructure, we decide that we need a new road, or we decide that we need a new railway, and we retrofit sustainability aspects to that design. It's a post hoc consideration. We decide that we want a third runway at Heathrow, just to use a parochial example, and then we worry about whether we're going to be able to deal with the village of Sipson as a result. We worry about whether we're going to be able to deal with air quality in West London. And we retrofit against that predetermined decision. What we should be doing is setting sustainability goals as the starting point and allow infrastructure design to emerge from a definition of what we see as a future of sustainable infrastructure. Sustainable infrastructure is infrastructure that is determined by the Sustainable Development Goals. It is not infrastructure that is responsive to perceived need and then retrofitted to give palliative care to the Sustainable Development Goals. This is what we do now. We need to stop doing it. And we need to set sustainable development visions, introduce societal aspects, and then develop design sustainable infrastructure, so that our sustainability agenda informs and feeds our decision-making rather than puts a brake on the progress of projects, which is the way it's very much seen at the moment. And the background to this slide is the number of different schemes that were looked at for the Severn Tidal Power Scheme in about 2008. The Cardiff to Western Barrage, that barrage there, would have given 5% of the nation's electricity from a single hydroelectric scheme. There were environmental concerns, but 5% from a renewable source for 120 years would have allowed a high level of investment in environmental protection. But because it was decided on a cost-benefit analysis basis, it was rejected by government. If you had set the sustainability goals for your electricity generation for the future, this might have had a different outcome. So the Sustainable Development Goals have been discussed already. And there are not many that are not impacted by SDG 9. But infrastructure tends to be the poor relation in the SDG discourse because it is so widely understood to be a deliverable of a normal society that we don't understand and we don't accept and we don't explore the extent to which improving the way in which we deliver infrastructure could improve the whole of our performance against the SDGs. If we decided that a sustainable development in a future society would reduce the demand for travel and we would improve connectedness at low carbon cost and we would increase the quality of life and reduce poverty as our outsetting goals, not at a political level, but at an infrastructure design level, where we are getting down, where engineers would have to take responsibility for this agenda setting, we would end up with very different physical infrastructure, which would then allow the SDGs to be more closely met. My experience so far is that I suffer from having sustainable development in my job title. And to try and explain that outside the working context is very difficult. But when you start to, and particularly to engineers, but when you start to talk about resilience, engineers feel immediately more comfortable. They feel immediately that they have some kind of relationship with this phrase, some kind of understanding of what that might mean. It may be incomplete, and using this kind of graphic can help them to develop that understanding. But we should, I think, take resilience as some kind of proxy for sustainable development in an engineering, particularly a civil engineering context, where engineers responsible for crucial decisions may be more easily persuaded to embrace this kind of agenda than they feel when faced with sustainable development, which generally they find rather overwhelming. Thank you very much.